Hi everyone, welcome to our favorite channel, Digu Science. This channel presents educational materials in animated form. We hope this animation is helpful. This time, we'll discuss transformers. Here's a soft iron core. This material is shaped like a block, with a hollow center. It's similar to a toroid, but rectangular. On one side is a coil of wire wound around it. This coil is connected to an AC voltage source. Therefore, this coil is known as the primary coil. On the opposite side is also a coil wound around it. This coil is connected to an electrical load, which can be symbolized as a resistor. Because it's not connected to a voltage source, this coil is known as the secondary coil. Now, consider the primary coil. When electric current flows, a magnetic field is generated. This magnetic field spreads out in the space around the coil. There's something interesting here. When a certain material, such as a soft iron core, is inside the coil, the magnetic field lines actually gather within the soft iron core. This is an important concept we must understand together. Let's return to the original electrical circuit. The voltage source used is an AC voltage source. We know that this voltage source produces an alternating current. What does this mean? It means that the magnetic field lines formed inside the soft iron core are constantly changing both in number and direction. What does this mean? It means that the magnetic flux is changing. Changes in magnetic flux produce an induced EMF. If you've ever watched a video about mutual induction, you'll understand. The change in magnetic field lines is caused by the primary coil. The magnetic field lines also reach the secondary coil. The change in magnetic field lines causes a change in magnetic flux. The change in magnetic flux in the secondary coil produces an induced EMF. Therefore, the induced EMF in the secondary coil is caused by the change in magnetic flux in the primary coil. This is the second important concept we must understand. Let's analyze this. Let's assume the source voltage is Vp. The subscript P here stands for primary, as it refers to the coil. The number of turns in the primary coil is Np. Similarly, in the secondary coil, there are Vs and Ns. Using the concept of induced EMF, in the primary coil, Vp is equal to minus Np d phi dt. At the same time, in the secondary coil, Vs is equal to Ns d phi dt. Since the flux change in both coils is the same, we can compare the two equations. Vs over Ns is equal to Vp over Np. This is the transformer equation. Knowing this equation, we can determine the secondary voltage by changing the number of turns in both coils. We will discuss this further in the next series.